how to implement a modern day latest AI-based high throughput enterprise grade logging and SIEM solution for your application, which can cater to both audit logging and FinTech level of logging requirements. So this is the architecture in front of you. Before we jump into the architecture, we will first talk about why we select each piece of technology here. The logs are going into Elasticsearch from different microservices as you can notice. So starting from the Elasticsearch first, we will discuss why Elasticsearch. So you may think we have been having traditional RDBMS databases like SQL Server, Postgres, and other databases, but we choose Elastic because the way it stores the data. Normal RDBMS, they have been storing the forward index like clustered, non-clustered, composite, and other type of indexes, which are very useful for millions of record searching, numbers, and all those things. But when it comes to text-based searching, the index is very different. It is a new type of index, which is called inverted index. So this Elastic database, it uses the underlying engine called Lucene engine, which stores inverted index. So the keyword search is definitely way beyond the normal RDBMS search, which is why industry have moved for storage of all these text-based information to Elastic type of databases. And then, of course, we have full text search and the inverted indexes in SQL Server also, but they were not geared more towards this feature. They had it as an add-on, but Elastic, it can at the same time do horizontal scaling for that. So it's more geared toward that technology. And when it comes to Elastic, there are other competing solutions also. But Elastic definitely, when we talk about the free solution, it has all the features of enterprise grade requirement, which is why it's the best suited. Plus, it's best suited for the years and years of storage of data. And plus, it has all the inverted indexes features. So when you talk about the free open source solution, Elastic is the de facto standard, which all big organizations are using these days. But when you, if for example, you look for the Splunk, it also have all the features, but then it's a paid solution. So Elastic give you this benefit, and latest 8 plus version Elastic, it has a specific logs DB mode, which is even better. It gives you up to 65% smaller log indices, more storages, less infra costs. So you talk about 7-10 years of logs that you can store, and then you can keep it as a for your auditing purposes. Then having said about Elasticsearch, then now we'll talk about the log ingestion tools, basically which agent would you use to push the logs. This is very important because especially in application like Node.js, the consideration is speed and performance. So legacy, we had this Winston library, which is very feature rich, and it's very old and still very famous. I mean, it has the highest stats, but when it comes to performance, this latest library is much better. It's known for its high speed. It's not that feature rich, but it is much better for the high performance systems, which is our need. The video is about high throughput. So we have chosen this particular library, Pino. So it has certain features over Winston, and it's becoming very famous also. Normally, high amount of downloads also. Winston, it was designed basically for the monolithic age. So it was good enough for its time, and it's still being used in many applications. It has a lot of features, but sometime when it comes to performance only thing, then Pino is your solution best. So it's extremely fast. It's async also. So by all means, this is the best solution for the high throughput, which we are going to use. So when we talk about .NET, Serilog is definitely the fastest among all. There is Nlog also, but as per the statistics and the comparison on the benchmarks, Serilog is the fastest for that. When it comes to Rust language, there are a number of options, but FastRace is the best one. And when it comes to C++, Nanolog is the top one, which is famous for its ultra low latency logging. So there are a number of libraries that we have here. So here we talked about Pino, the Node.js agent, and we talked about the agent that we can use for other languages or other microservices to basically help us with the pushing of logs. So basically here we have the reference design for it. By the way, when we talk about Elasticsearch, we will first refer to what are the designs that Elastic teams recommends basically, or what are the recommended architecture for the Elastic itself. Elastic does come up with its own Elastic agent, which is called FileBeat. You see, for Elastic's FileBeat agent. Normally people, they tend to use Kafka and other technologies. However, the thing here is this agent from the Elastic is more geared for the requirements of Elasticsearch. It's much better. So having Kafka is either redundant or not needed, which is why if you notice, the normal recommended design is just Elastic agent pushing the logs to Elasticsearch. Or you can have Kafka, but in case you already have it as your middleware, otherwise it's not needed. This is not one of the recommended design, neither for the simpler one, neither for the air-gapped one where you do not have the internet access. So the normal flow is like this. Because this Elastic agent does all the things that Kibana can do for you. It can do the retry for you. It can do the buffering for you. It already does that. So it is self-sufficient for keep doing the retries and buffering and all those same thing that Kafka is doing for you. So having Kafka is only a redundancy, extra infrastructure, extra security vulnerabilities to look into, extra storage that you need to manage, so that you can cut short into the Elastic recommended design of having just the agent. So this is basically a Kubernetes design. If you are looking at, this is a Kubernetes pod, and you have a sidecar pattern where the basically two containers are in the same pod. And you have a shared volume. So the app container for the Node.js, if you notice, it has a Pino logger configured. I'm going to show you how it's basically configured. We have a demo also. So it's writing to this shared volume. And from this shared volume between the two containers, FileBeat container is basically picking the logs, reading them, and then pushing them to Elasticsearch. So we have the rotation policy configured in the Pino that last 5 log files to keep. Each file is going to be 1 MB, and then the rotation will happen. So if you see in my second picture, you have last 5 files there, and the 15 file is being written to the log. And the reason why you are not going to lose any piece of the log is these two containers are basically in the same pod. They are going to initiate with each other. They are essentially like two threads. One is the Node.js threads, and another is the FileBeat thread. And having them as a sidecar pattern, the benefit is the FileBeat container will run in its own constrained CPU, will have its own, containerized environment. It is not going to affect the whole application. Suppose your application crashes, the logging engine will continue to work. So the both are isolated. It is the most recommended design for the logging, by the way. So the read and write are split. You are writing here into the logs on this container, and you are only reading from here. Also, it gives you another benefit. If, for example, the log ingestion is very heavy at the FileBeat level, then it is not going to affect your main application. Plus, you can do the sizing independently. You have the huge load of ingestion. You can scale this container regardless to this one. So this gives you another edge, because the Elastic, the benefit is the inverted index, but at the same time, ingestion is costly. So all the load goes here for the FileBeat. But it can definitely, being a separate container, can cater to this load. Now from here, basically, we definitely will configure it to, as we talked about, a special mode of logsdb, so that we get extra compression and 6-7 years of, or maybe a decade of logs you can keep here. It is another container only with a persistent storage of 200 GB to start with. And it does automatically self-management. You can evolve into a cluster. I have started with just a container, single container. And my configuration for Pino is, as I just explained, is 1 MB file to rotate every 5 minutes. I'm going to show in a demo also, and it's going to automatically remove other files, because otherwise this container, if we are not going to rotate, it's going to get filled up over the day period of time with heavy amounts of logs. So we need to have a rotation here. And as I already explained, there is no chance of missing any single log entry, because these containers are working in a same coordinated pod. So they are going to create it together, and one is going to write, another is going to read, and then they are going to keep up with each other. So since they are very much associated with each other, so there is no chance for missing any single log entry. And the rotation and the cleanup is also getting done automatically through this Pino role. It's an additional module for Pino that is available. Plus, another good benefit is with Pino, you do not need any extra web worker to offload your logging, because it automatically has this sync setting. So if you notice, you can just configure the sync flag here. So which means it will put you into high throughput mode. Plus it has special modes also for the Pino where you can set it for the high throughput or other configuration, so that further performance gain you can keep. So having done for the ingestion layer, you come to Elasticsearch here, where basically you are keeping all your data. You definitely get the benefit of inverted index. And then there are two outlets to it. One is going to your Kibana or Grafana. If you want visual space, some people do not use that. They just do the raw REST API queries to the Elasticsearch and then render on their desktop. But if needed, you can have your Kibana also for the SOC team to visually analyze the data. At the same time, you can have another RAG pipeline, which is building up the context and feeding some of the information to the vector DB, so that you can have a basically AI performed on it. You want to scan the last 2 hours logs to check why particular service went down. This AI can naturally give you benefit. Instead of searching last 2 hours of log yourself, you could use your LLM to intelligently do that for you. So this is a good use case. Basically, these modern days logging technique is around that. And slowness also you can cover with high telemetry. Every type of log getting covered, you can do that also. So this architecture is basically uh, provide you all type of logging for the FinTech. When we talk about FinTech, there is an additional need. You want to add the immutability to the logs that are going to get delivered to the Elasticsearch database. So basically that can additionally be very easily added. And I'm going to show you in the demo how I'm going to add that. Basically, we just add a small function which calculates the checksum of the log while it's getting shipped to the file. And then you basically add a hash to it, and then you ship it, so that when you are storing that log in the Elastic DB, you have the integrity value, which is essentially the checksum. So in case the log is tempered or manipulated in root or in the DB itself, somebody changed the value, the checksum will mismatch. This will give you the clue that that log have been tampered with, so it can cater to your security requirements. So this solution is ready for the banks also, because it has all the scalability measures of Kubernetes scales, and it has the Elastic cluster in front of it. So it's an enterprise grade high throughput solution. So coming to the demo now, in front of you, Node.js backend application, which is implementing Pino based log ingestion. These are the Pino configurations. This is how injection of Pino is getting done here. And basically, this is my Docker Compose. In a nutshell, we are containing one single Elasticsearch container to start with. You can have a full cluster later on, but to start with, you can have a single cluster, single container. And then you have two containers. One is sidecar file B, another is your main application. These two containers are basically in the Kubernetes, going to be in the same pod. For the sake of Docker desktop, I'm configuring them as single separate containers with a shared volume. So if you notice, my app is there and there is a one shared volume, log volume, and the same log volume is shared with my sidecar, so that my application is going to write logs on this volume and my file beat container is going to read from that same thing. And this file beat is dependent on that app, so that there is no race condition. In case of Kubernetes, this is going to be more seamless because they are going to be contained in a single pod. So we have just one log volume and a shared network between them, and then single Elastic container to do all of this. And then we have in our application simple endpoints. Like we have, for example, one graph query to console log the message that say hello, and another is loop hello, which is going to do the same thing 3,000 times. So we are going to really see how the logs are going to get populated and the performance and the real time factor of the solution. And then there is another point just to log any custom message that we might be having, so that we can see and see how the changes are getting reflected in our Elasticsearch container. And then we have a last, which is called log with checksum. Log with checksum is just an additional layer. If you notice, we are just simply logging here in all of these above function, but here we have with checksum. So we are basically in log with checksum. We are just doing some crypto here. We are creating the hash and then we are doing it a digest way, so that the same message, it has an integrity field also. So this is our simple setup. We'll come to our REST endpoints. We have two ways to invoke them. Like for example, here we got the response here. There is another way to just say hello, and we are getting the response just to say here, for example, we are getting the response here also for all times that we are clicking here. And at the same time, we can see, for example, from our containers, let's suppose we go to the sidecar container and we want to see how the logs are getting appended. So if you see, these logs are there as a shared volume. So if I try to query my Elasticsearch, for example, here, like for example, how many indices we have. So these are the two indexes that are there created. And if I want to query how many events are there, so 30,000 events are there already because I called the few that 3,000 times of pushing the logs. So the logs are accumulated there. And let's suppose I want to query in first 50, for example, logs. So here I'm getting all that. If I'm going to search for example, hello. So you see, hello endpoint hit from the final logger. And let's suppose we try to invoke one of the encrypted endpoints. Let's suppose log with checksum, send request. And this is response for the log with checksum. So then again, we'll query again for the 50 latest records. Here we get it. And we want to checksum. You see, head point hit with checksum. So we are getting the real-time update on whatever endpoint we're hitting. And then at the same time, we want to check with the behavior of log rotation also. So let us hit another endpoint, which is looping on the number of messages. So this is called loop hello. So loop hello, as I showed you already, it is going to do it 3,000 times. So we want to see the behavior of how logs are going to get populated. For example, if we see here, this is the last log file. This was updated 57 seconds before because I was clicking on that sending message, but now I'm going to bombard it. So this is going to be my request, and it's probably landing there. You see now the log started to grow. If I'm going to edit that file, I'm going to see it's rapidly increasing the size of the file. Logs entries are getting populated, and you see now it's rapidly increasing in the size. At the same time, the file beat container is reading it, but speed logging is happening now. So what we are going to actually see is the log rotation also. This is, as I mentioned, the limit is set to 1 MB. When it's reached to 1 MB, it should automatically rotate and no log event should be missed. All of that should be captured in the Elastic through the file beat. We are going to see that by querying last 50 logs just when it's when it done its rotation part. So it's reached to roughly 900 KB. Let us see. So roughly 936 KB, 943. So 964, 70, 80, 991. And here you go. You see? So you at any point in time, you are only going to have last 5 extra logs. So total storage of this container is never going to exceed more than 5 MB as far as the logging is concerned, because we have the parallel file beat container logging. You can configure it to 10 MB also, but there is no use for keeping extra logs here once you are relying on the Elasticsearch for keeping all those data. So at the same time, what we will lastly want to see is last 50 logs. Again, because we just pushed the new logs and we want to really be real time on this. So if you see, now I'm going to search them. The number of message definitely increased. So I'm going to search on hello. So you see 2196 times. So